Bismillahirrahmanirrahim. This video is about ideal transformer, chapter 13.5, and here we'll be discussing example 13.9, for which a request has been sent by a student. So let's see. This is the question: calculate the power supplied to the 10 ohm resistor in the ideal transformer circuit. So this is the ideal transformer circuit, and 10 ohm resistor is this one. So we have to calculate the power in this resistor. So power supplied, we know the formula for power is I square R. So since I in this is I2, so we'll write I2 square and R is 10. And to find this, actually what we need is to get the value of I2. That should be our aim. Now, a point to remember that in the previous example, we had a circuit like this, where the transformer was, the two terminals were coupled, and the secondary load or the secondary resistance can be easily transformed to the primary side by using this formula, and then we can solve this by KVL. This circuit is slightly different because the two ends of the transformer are connected through a resistance to the ground, and therefore we cannot then use the to transform this or to reflect the load. So we have to use the mesh relation or KVL. Okay, now the first thing that we will do is this is the circuit. So keeping in view the current direction, or we can assume any current direction, we'll mark the polarities across the resistors, etc. So that, so wherever the current touches first, I1 is touching here first, so that will be positive, other negative. This is already marked, here it is positive and negative. And similarly for the other side, now it will be touching this place first, so it will be positive, negative. This is already given, and this will be positive at the top, negative at the. Okay, now let's write the mesh equation. I prefer to start from any one corner. So let's say we're starting from here. We have minus sign, so minus 120, and angle 0, we don't need to write angle 0. This is, and then it is 20 I1, then we have V1, and here there are two currents, I1 and I2, so we'll write 30 I1 minus I2 equal to 0. So this is for the left mesh, and we can simplify this. If you just open this, this will be the equation. And now we come to the right mesh. We start again from one corner, we're starting from here. It is 30, and now since we are in the mesh 2, therefore we assume that I2 is superior, so we'll write I2 minus I1, and then minus V2, and plus 10 I2. And here also we open and collect the like terms, so this will be our second equation. Now we need a couple of at least two more equations to solve for I2. So we'll use the transformer relation, and in the book there are many options given. I've only selected the one which is related to our figure, the dot at the top and the dot at the bottom on the right hand side. So for this, the relation between voltage and current is shown here. V2 over V1 is minus N2 over N1, and current I2 over I1 is minus N1 minus N2. Now in case of a current, this goes different, N2 here at the top and 1 here at the top. So use that. So the V2 V1 is minus N2 N1. Now if you look here, N2 is 1 and N1 is 2. So add 1 over 2. And from here we can write that V2 is this relation. So this is our equation number 3. And similarly for current, using this formula, it is now N1 divided by N2. So N1 is 2 divided by 1 is 2. So minus 2. And from here, we get the fourth equation for I2. So these are the 4 equations. Now our goal is to get I2. So the first we will be eliminating from here I1 or I2. Let's further simplify this. We can write from here E1 is equal to minus 2V2. And similarly from here I1 is minus 1 over 2 I2. We'll be using V1 and I1 in this. Let's first of all put the value of I1 in equation 1. Here we want to get rid of I1. So we'll put this so we get I2 and V1 in terms. So putting in the value of I1 and then solving, we get equation number 1a. And coming on to the second equation, and now in this equation also we'll put I1. That will eliminate I1. So we have another equation which only has now I2 and V2. This one has I2 V1 and this one has I2 V2. So here also we'll be using this relation to get in terms of V2. These were the two relations. Putting V1 is equal to minus 2V2 into equation 1a. So this will become minus 2V2. And now if we add these two, 55I2 minus 55I2 cancelled. And here we have minus 3V2 is equal to 120. Minus 3V2 is equal to 120. And therefore V2 is minus 120 over 3 is equal to minus 40 volts. V2 we have found. And now putting in this equation 2a or this equation, we can find I2. So therefore, from equation 2a, equation I2 is V2 over 55. Using this equation, and now we plug in the value of V2, 40. So we get the answer of current to be 0.727 ampere. So the current we have found, and now we need to plug in into the power formula. So this is the power formula, plugging in the value of I2. So power is 5.3 watts. I hope you have been able to follow this. Simple question. Please let me know. Thank you.